Hello, in this video I'm going to be explaining the ratio test. The ratio test basically means if we have the series a sub n and we replace all n values with n plus 1, we'll have this new equation a sub n plus 1, like right here, and if we divide it by the original a sub n, then we will have this new ratio, or this new equation here. If we take the limit as n approaches infinity of the absolute value of this new equation, and the returned value is less than 1, then we can conclude that the original series is convergent, or it's actually called absolutely convergent. If the limit as n approaches infinity of the absolute value of the same equation is greater than 1 or equal to infinity, then we can conclude that the original series is divergent. Otherwise, the ratio test has no conclusion, but that's only when this value, the value you get returned from this equation here, is equal to 1. The ratio test will have no conclusion, and we would have to use a different test in order to evaluate the original series. So less than 1, if the value is less than 1, then it's convergent or absolutely convergent, and if it's greater than 1, basically greater than 1, then it will be the original series will be divergent. For example, if we have this equation here, series of n times negative 3 to the power n divided by 4 to the power n minus 1, and if we want to use the ratio test on it, the first step we do would be to take the limit as n approaches infinity. So the limit as n approaches infinity, and we will take the absolute value, and we're going to replace all n values with n plus 1 to start off. So here's an n here, we'll take n plus 1, and we're going to be timesing that by negative 3. I'm trying to write around this camera. And then we're going to replace this power with n plus 1, so n plus 1. So that'll be the first. And then we're going to divide this by 4. We're going to replace this n with n plus 1, so n plus 1 minus 1. And dividing is basically the same as multiplying by the reciprocal. So I'll write it out. But if we're going to be going straight at it, we're going to divide by the original. So we would divide by n minus 3 to the n power 4 to the power n minus 1. That's what it would originally look like. That's a 3. This is what it would originally look like, but since dividing is the same as multiplying by the reciprocal, I'm going to do this instead. We're going to take the limit as n approaches infinity of the absolute value n plus 1 times negative 3 to the power n plus 1. And I'm going to divide that by 4 n plus 1 minus 1. This is the same as multiplying by the reciprocal. So we would flip this equation. And we would get times 4n minus 1 divided by n negative 3 to the power n. I don't know if you can see that. There you go. So this is what we basically have. I can see, first of all, that we got a 4n minus 1. So this right here, and we got a 4n plus 1 minus 1. So if we canceled out the 4n minus 1 here, and the 4n minus 1 here, we would get 4 to the power 1, positive 1, which we would have 4 left. So this is still 4 there. And nothing here. Or 1, actually. Next I see that we have negative 3 to the power n and negative 3 to the power n here. Negative 3 to the power n would cancel, but we would still have a positive 1, so there would be a negative 3 here as well. These would cancel, and we would still have a negative 3. There's an n and an n plus 1, but those won't cancel. So next what we will have is the limit as n approaches infinity of negative 3 divided by 4 times n plus 1 divided by n. Let's see, we can take this and pull it out to the outside. But remember, when you take a negative value and pull it out of an absolute, then we will get a positive value on the outside. So we would actually end up with 3/4 times the limit of n approaches infinity of n plus 1 divided by n. So if we want to take the limit, we can see here, grab a different marker, that we have, this is a 1 here, and this is a 1 here. That's not ln, that's just a 1. We can conclude that, since these are the greatest values, that the limit as n approaches infinity of this is equal to 1. So the limit is equal to 1, and we have 3/4 times 1 as the last bit. So then we would get 3/4, and 3/4 is definitely less than 1. So since 3/4 is less than 1, our rules stated that if we get a value for this equation that is less than 1, then our original series is convergent. So we can state that our original series right here is most definitely convergent, since you got a returned value of 3/4 that is definitely less than 1. So we can conclude that it is convergent.